When solving systems by graphing, it is generally helpful to transform linear equations into slope-intercept form because it usually saves time in the end. It also makes it really easy to check your work. For example, we have solved the following system of linear equations by graphing. And the two equations we have are 2x plus y equals 5 and negative x plus y equals 2. Neither of these equations are in slope-intercept form. So the first step, step number 1, should be to rewrite the linear equations in slope-intercept form. You need to solve both of the equations for y. In both of these equations, it takes just one step to solve for y. In the first equation, 2x plus y equals 5, we can subtract 2 from both sides to get y equals negative 2x plus 5. And in negative x plus y equals 2, we can add x to both sides to get y equals x plus 2. The second step would then be to plot the y-intercept and use the slope to plot the second point, or as many points as you need to see that point of intersection. So because both equations are now in slope-intercept form, we can immediately see that y-intercept and the slope. The first line is graphed in green. It was very easy to see from the value of b that the y-intercept was 5, and from the coefficient of x, m, that the slope was negative 2. So from 0, 5, we can then move down 2 and right 1 and graph our first line. Then we can do the same exact thing with the second line graphed here in orange. We have y equals x plus 2, so it's very easy to see that y-intercept of 0, 2 from b, and the coefficient of x telling us the slope of m equals 1, so that tells us to go up 1, right 1 from 0, 2, and then we have our system. The third step is to locate that point of intersection and then to check our work to make sure the solution is correct. We can see the point of intersection here is 1, 3, and substituting in the value where x equals 1 and y equals 3 into both equations, you can see produces true statements for both, so that is a solution. Let's do the same thing one more time. Let's see another example where it says to solve the systems of equations graphically. We have 2x plus y equals 8 and x minus 2y equals 4. Neither of those equations is written in slope-intercept form, so that's our first step. We want to rewrite both of them in slope-intercept form. We want to solve both of them for y. The first equation, 2x plus y equals 8, is one step to solve for y. You subtract 2x from both sides of the equation, making it y equals negative 2x plus 8. But the second equation, you have to do two steps. The first thing you have to do is subtract x from both sides, and that gives you negative 2y equals negative x plus 4. And then you have to divide everything by negative 2, so that will give you y equals 1/2 x minus 2. The second step is now that your equations are in slope-intercept form, you can easily see and plot the y-intercept, and then use the slope to plot a second or however many points you need. So the first equation had a y-intercept of 8 and a slope of negative 2, so that gives us the first line. The second equation had a y-intercept of negative 0, negative 2, and a slope of 1/2, so now we can find that point of intersection. That point is 4, 0, so substituting in, checking our answer. If we substitute in x equals 4 and y equals 0 into our two equations, and again, look how I'm not using the original equations when I check my work. I'm checking those slope-intercept form equations. I do get true statements, and I can see that that is my solution. So when solving systems by graphing, make sure both of your equations are in slope-intercept form. It will save you time and make checking your answer easier.